Welcome to math class. We are continuing on in the MathWorks 10 workbook. We're starting chapter 3, looking at the beginning of length, area, and volume. And what we're looking at today is the systems of measurement chapter 3.1. So we're going to run through a few examples looking at the kind of measuring skills that we're going to need to get through this particular chapter. So if you've opened to page 119, they have an example of a shape on there. I'm going to try and recreate it. Probably not very well. Go here, down, up, and then up like that. So that's a terrible recreation of the shape in the textbook. But they've got some measurements for this. 2.8, okay, 2, 2.1, 2.0. 2.6 and 4.4 centimeters. So what they want you to do is add up the perimeter of this particular shape. Now this might be reviewed from grade 9. It should hopefully be reviewed from grade 9. Sorry, I gotta pull up my pen here. Perimeter is the edges of a shape. They basically want to know the total distance of a shape. I always call it you want to build a fence around something. Okay, so the way that's going to work, if I can pop this up, let me take a pause. Okay, sorry about that, a little interruption. So back to perimeter. So what we're looking at is we need to add up all of the edges. So equals side plus side plus side, continues on forever, depends on the number of edges. So what we have here is we need to add up all of these edge distances. So I've got 4.2 plus 2.8 plus 2.2 plus 2.1 plus 2.0 plus 2.6 plus 4.4. All I've got to do is punch all of those into my calculator, and I wind up with a total of 20.3, sorry, it's not a 3, 20.3 centimeters. Let me erase that so it's not quite so ugly. So we've got 20.3 centimeters as our final answer. So that is the perimeter of all the shapes. So that's how you solve perimeter. You basically just add up all of the shapes, or sorry, add up all of the edges to get a total distance that runs the border of your shape. Okay, so that's how we deal with perimeter questions. So let's take a look at our next little example. Okay, so let's flip open to page 122. On page 122, they have a uniquely shaped flower garden, and they want you to figure out the perimeter of the flower garden. So now we have a slightly more complicated but same idea. So their drawing looks something like this, except they didn't have the lines in the middle. Something like that. So we know that this leg is 4 meters. They know that this distance across here is 2 meters. Right? Now what they're looking at here, our perimeter is still just adding up all of our edges. Problem is these rounded edges right here. I can't add those. I don't know exactly how long those are, and I can't add those up. So what I need to do is break this down into its different shapes. So what I actually have is I have a 4 meter by 2 meter rectangle, and I also have 2 half circles with a 2 meter diameter, or I have 1 whole circle with a 2 meter diameter. And what I need to do is combine the total distances of both of those. So I'm going to need my circumference equation. Circumference is a fancy word for the outside edge of a circle. So circumference is going to equal pi times the diameter, or c equals 2 pi of the radius. I'm sorry, 2 pi times the radius. We know our diameter. So diameter is the distance that goes all the way across a circle. Judging from our picture here, this looks like it's going all the way across the circle, so we can comfortably say that our diameter is 2 meters. So if I punch that in, I use my calculator, pull up pi times 2, and I get an answer of 6.28. So my C equals 6.28. I also need my area, sorry, don't need my area. Okay, I need my perimeter of my square. So I have side plus side plus side plus side equals 4 plus 4 plus 2 plus 2 equals 12. Oh, sorry. I did that completely wrong. Getting ahead of myself. I don't have to count my 2-meter sides because they are inside of the circle. Okay, so those 2-meter sides don't count. What I really need to do is focus on the 4-meter sides. I'm getting a little too ahead of myself. So I have my circumference of the circle. So my perimeter is going to be my circumference plus side plus side. 6.28 plus 4 leaves me with 14.28 centimeters, sorry, meters. Okay. So my final answer there is 14.28 meters. Now, you won't necessarily, for the next couple questions, you won't always have to deal with circles per chance. What they're trying to get you to do is understand that even in a shape like this, I can break it down into the different composite shapes. So all the different pieces, I might have half a circle or full circle, half a triangle, full triangle, half a rectangle, a full rectangle, so on and so forth. So you need to recognize the individual parts of those shapes and then use the formulas you need in order to figure out their distances and combine them. Okay, so that's how we deal with perimeter and perimeter of tricky shapes. What they want us to do with next is we're covering some new material. We're looking at the imperial system of measurement. We're looking at feet and inches. Okay, so they've got an example on page 124 of Wilhelma. I don't know if I pronounced that right. Oh, sorry, Wilhelmina. Wilhelmina. So she's a seamstress. She has to order fabric. Fabric is in yards. Okay? Looking on page 124, they give us a handy little conversion. 1 yard is 3 feet. Okay? That's going to be important to keep in mind a little bit. So what she needs, or what she's got, is she has 3 3/4 yards of silk. She has 1 1/2 yards of lace and 7 1/4 yards of trim. Now she needs to make 5 dresses. And what they want to do is understand how do I take a 3 3/4 yards and convert it and figure out how much I need for 5 dresses. So if I have 1 dress, I need to convert it into 5 dresses. So how much material do I need for 5 dresses? Man, I can't talk today. Okay, so what they want you to do here and what we're looking at is just a quick review of how we multiply fractions, right? So all we really have to do is multiply each of these by 5. Okay. So I have 3 3/4 of a yard, so I multiply it by 5. What I get is, right off the bat, I'm going to get 15, and I'm also going to get, 15 over 4. All right, so what I did is I broke this down. I've got 3 3/4. So I went 3 times 5 equals 15. I went 3 times 3/4 equals. So this should be review from grade 9, but anytime I'm multiplying fractions, all I'm doing is multiplying straight across. Okay. Oh, sorry, I have 5 over here. That's why this wasn't making any sense. Okay, so I go 5 times 3 to get 15. 1 times 4 gives me 4. Now there's a problem with that. That's an improper fraction. I know that 4 goes into 15 multiple times. In fact, I know it goes in 3 times with 3 left over. So now I'm going to go ahead and add this in here. So I know that 15 over 4 is incorrect, and I know I've got 3 extra whole numbers. So I had 15 and 15 quarters, and that actually winds up turning into 18 and 3 quarters. So that's one way to solve it. The other way to solve it is to convert it into a decimal first. So if I go back here, let me erase this. So let's look at our 1.5 yards of trim. Okay. So I need to convert 1 1/2 into a decimal. Okay, well, I know it's going to be 1. I've got my whole number here. I'm going to go 1 divided by 2 equals 0.5, which means that 1 1/2 is the same as 1.5. Now I take that number, 1.5 times 5. That gives me an answer of, now I believe, 7.5 yards. So I'm going to head over here now, and I'm going to put 7.5 yards. I also, since this one is in a fraction form, I can convert this back to a fraction. I know that 0.5 is going to be the 1/2 fraction. So I can turn this into 7 1/2 yards. All right, and one other method. So the other method is, in order to make it, to kind of decrease my steps a little bit, is I'm going to convert my improper fraction, convert to an improper fraction first, and then I'm going to multiply by 5. So I've got 7 1/4 times 5. So the way that I'm going to do this is I'm going to go 7 times 4 plus 1. So now I get 29 over 4. And multiply it by 5. Okay. So 20 times 5 is 100 plus 9 times 5, so 145 over 4. So I get 145 over 4. Okay. Now I have to break this down. So 4 goes into 145 times. Let me pull up my calculator. Do I have it handy? Apparently I do not have it handy. Okay. So I pull up my calculator and I'm going to punch this in. So 141, I don't want that. Okay. Not sure what's going on here, but my calculator doesn't want to work with me apparently. Okay, I'm going to try and get rid of this pesky calculator. Okay, so 145 divided by 4 actually gives me 36.5. So I know that I've got 36 whole numbers. Okay. And I know that 0.5 or half of 4 is 2. So I have 36 and 2/4, or I could do it as, since I'm reducing whenever I can, 36 1/2. So I get 36.5 or 36 1/2 yards. Or sorry, 1/2. Yeah, 1/2. Okay, so that's how we do those particular questions. All right, so our next example here, I'm going to be moving on down. Our next example is on page 127. All right. Now the example on page 127 is a bit of a unique one. What they're doing is looking at how do we add up feet and inches. It would be simple if 15 feet 8 inches was the same as 15.8. But it's not, and it's a very important thing to remember. 15 feet and 8 inches is not the same as 15.8, and I'll show you why. 15 feet, 8 inches. How many inches are in a foot? 12. Okay, so what I actually have here is 15 feet and 8 out of 12 inches. 8 divided by 12 is going to give me 0.75, okay? Not 0.8. It's important to remember, because there's 12 inches in a foot instead of 10, I cannot convert feet and inches into straight decimals. Okay? So what happens if we have a shape like the example on page 127 of it looks like it's a house. We've got a basic square edge here, the little divot there. Coming up, I have a door. I'm not very good at drawing these. Yeah. There we go. So we have a shape that looks something like that. This one is 15 feet 8 inches. This one is 9 feet 2 inches. We have 6 over here. 27 inches, 5 foot 2 inches. We have 9 inches right here, 9 inches right here, 2 foot 6 inches. And we have 24 inches right there. Okay, so there's a couple things going on in this one. The first one is that they're going to try and get you to think a little bit outside of the box. You have to use what you do know in order to figure out the things that you don't know. For example, if we look over on this side of our figure, okay, I know this stretch of here. I know exactly how long and how big that little piece of wall is. They tell us it's 24 inches. I don't know this one, or this one, or this one. I don't know how big or how long those are. But the question is, does it matter? If I don't know these three specifically, what I do know is that all three of these is going to add up. So we'll say Mark plus Mark plus Mark is going to equal 9 foot 2 inches. Because look, this edge, not on my drawing, but in the textbook, is the same. This and this is a straight line, so the distance between here is going to be the same as the distance between here. It just so happens that there's a couple extra little bumps along the way. So that's an example of figuring out what we do know, or using what we do know in order to figure out the things that we don't. Okay. Then the second part of this is going to be looking at how do we add up big totals of feet and inches. Okay, so I have here. So I have a perimeter. I believe that's what they want me to find. Yeah. So perimeter equals 15 feet 8 inches plus 9 feet 2 inches. Okay. Plus, so now what I'm doing here is basically going through all these sides. So I've got that one, that one. I've got 6, 6. Okay. Plus 27 inches plus 5 foot 2 inches. Okay. This one is going to be 27 as well, plus 27 inches. Okay. I've got 2 of those. So plus 9 inches plus 9 inches, and I'm not going to count the door. The reason is we're trying to install baseboards. Don't install baseboards at the spot where your door opens into the room. Okay, now this is that tricky part. Remember, I don't know this, and I don't know this one or this one. But I do know that I can add up all 3 of those together with one number. And then the very last thing I'm missing are these 2 edges here. On my particular picture, they're a little bit cockeyed. They're not set up equal. But in the actual textbook, we have 24 inches plus 24 inches. Okay. So what we've got to do from here, let me scroll down a little bit, is now I'm going to add up all of my, use a different colored pen, I'm going to add up all of the feet first, just because it's the easiest way for me to keep this in mind in my head. So I've got 5 by 2, 27, 999 plus 9 foot 2, and those are inches. So what I have for feet is 15 plus 9 plus 6 plus 5 plus 9. So 15 plus 9 gives me 24, plus 6 is 30, 35. So I have 44 feet. Yeah. Now I'm going to add up my inches. So I've got 8 plus 2 plus 6 plus 27 plus 27 plus, oh, I forgot 2 plus 2 plus 9 plus 9 plus 2 plus 24. That's supposed to be 4 plus 24. That's going to equal, let me pull this up and punch it in my calculator quick. So I've got 8 plus 2 plus 6 plus 27 plus 27 plus 2 plus 9 plus 9 plus 2 plus 24 plus 24 equals 140 inches. Okay. Now at this point, we're going to go back and continue to do the same thing we did in the last question, where I know that I have 140 inches out of, or over 12. Right? That's what this is similar to. I know that every 12 inches is a foot, so I know that I've got clearly much more than 1 foot. So I'm going to 140 divided by 12. It's going to give me 11.6. Okay? I'm going to ignore this for a second. I'm going to add my 11 feet over here. So now I have 55 feet. And now I'm going to go, let me give me a little bit of jot notes here. I need to figure out exactly how many inches are left over after that. So what I'm going to do, let me get some more space to work with here, is I'm just simply going to go 11 times 12 equals 132. 140 minus 132 equals 8 inches. Okay, so my final answer is 55 feet, 8 inches. Okay, so the baseboards, she's going to need 55 feet and 8 inches of baseboard. All right, folks, so that's how we deal with composite questions, particularly when we're dealing with different shapes, and how do we start to work with feet and inches a little bit. All righty, I will see you in class.